Okay, all right. So today we're going to start Unit 3, which is called functions. So what I'm going to show you is what functions look like, briefly what they are, because I want to spend a period in class showing you the real world functions so you can make the connections. And then afterwards, if there's time, we'll do some Regents questions. Okay, all right, let's. Okay, all right. So as you might have noticed, the title of this video is a day 2 lesson. Okay, so I'm gonna do day 1 in class with you guys because it's touched on a lot of real world examples, and therefore I would assume that you guys have a lot of questions. So I think that's the best way for us to conduct class that way. Okay, so if you want to write this down, function in introduction, all right, I'm gonna give you some definitions, and then we'll show you some problems, but it's not entirely related to today's lesson. Okay, not entirely. Okay, all right, let's start. So here now, after you have seen me in class and we've talked about real world functions, what I want to talk about then is ways to look at a function. Now, if you haven't seen me yet, let me just get this out of the way then, all right? All a function is that it's a relationship, okay? And moreover, it's a relationship between two things at any point in time. So let's call them X and Y. Okay, so remember in the 7th grade when you guys have to do proportional graphs and calculate unit rate, remember that? You have to draw a line, right, with the title, and then you have to label the X and Y axes, all that stuff. That's a function, right? That's a linear function, right? Meaning line, right? Straight line, linear function, right? So that's a straight line. So that's the type of function. So today we're gonna look a little bit deeper into what a function is and what they look like. Okay, all right, so first of all, 3 ways to look at a function. All right, so there are 3 categories, all right, or 3 methods of looking at a function. The first one is looking at a table. So I'm sure you guys remember setting up a table of values or a ratio table, right, in the 6th and 7th grade. More or less like that, same thing, okay? With the exception that whereas in the past, right, you would have a table of values like this, X and Y. We're just using different letters or words, okay? So input is represented by the letter X, output is represented by the letter Y. Now, if you look at it scientifically, right, the X then is the independent variable and the Y is the dependent variable. Okay, they're all the same thing. Now, I'm gonna introduce a couple more words for you here, all right, on the side here. Another way to say input is the word domain. So this is the domain. And another way to say the word output or the letter Y is the range, okay? So 3 things right off the bat, right? Input, domain, letter X, all the same things. Output, range, or the Y variable, all the same thing. But I'm gonna add one more thing to this, all right? You should probably write this down. This is actually gonna be really good for you, all right? Whereas input is the domain, is the letter X, output is the range, is the letter Y, but here's another one. Y is also called the f of X. F, and then in parentheses, the letter X, right? So this is why I said f of X, right? Which is a function. So meaning Y is a function of X, okay? So that's that's a very definitional term right there, okay? So meaning, right? So in class, one of the things I showed you was the relationship, let's say between time and money, right? So let's say in here we got time in the input, and let's say money in the output, right? Time, the money is a function of time. That's how we can write it. Okay, that's how we would say it. All right. In other words, how much money you're going to get depends on how much time you have. Think of it like that, okay? It's a very rough way of looking at it, meaning like not very sophisticated way of looking at it. But that's in a nutshell what that means, okay? So again, all right, range is the y, or the other way we write it is f of x, and that's the way we say it, which stands for the function of x, okay? So that's the first method of looking at a function. You look at the table, okay? The second way of looking at a function, I'm gonna get like way deeper into this, okay? We're gonna spend a lot of time on each one of these over the course of the next month. All right, so equation of a function, so that's what an equation looks like, okay? So this is a function of degrees. So this is the Celsius to Fahrenheit equation, okay? So Fahrenheit is a function of Celsius. Now let me write better. Fahrenheit is a function of Celsius. Okay, you don't need to don't get too caught up with the notation yet. Okay, just try to understand what I'm saying. Okay, so an equation, so table, equation, and lastly, it's a graph, which I'm gonna spend a lot of time with you in this week in class talking about. So this is a graph, right? So time and temperature, right? So in the day, right, during the day, the warmest hours is usually, right, like hours afternoon, so 6 hours afternoon, right? So 6 p.m. is the warmest time of the day. I mean, I don't know if that's true. All right, so that's what that is. So in other words, the temperature is a function of time. That's the relationship, right? What's the relationship? The more hours it is, the later in the day, the warmer it is, okay? The later in the day, the warmer it is. That's the relationship between time and temperature, okay? All right, so those are the three things. Now let's move on, okay? So in this segment, we're gonna talk about how to speak function, okay? Even though I taught you a lot about speaking function already, all right? Functional notation, right? So here we have f of x, right? Which is the same thing as y. So notice, right, how the two expressions, 3x plus 5 is 3x plus 5, right? Only on this side is it different, right? So here we got f of x, y, same thing, okay? So the input value here is the letter x, output value. So the question is something like this. The question is something like this. If I were to say, what's the f of 2, right? Meaning, if x were to be 2, what would this be, right? All you have to do is substitute, right? So this is just a good old substitution question. That's all this is. Nothing crazy here, okay? So one of the things that other teachers like to use a lot is think of a function as a machine, right? You put something into the machine, something else comes back out. So imagine putting like, what? I'm trying to think of a fruit. So imagine putting like a kiwi or a bunch of kiwis into a blender, right? And after it comes out of the blender, what does it turn to? Yeah, juice, right? Something like that. So think of that as a machine. So if I put 2 in, if I input 2, or if I put in 2, right? What's the output? 11, right? So think of it like this. Watch this. If x is 2, right? What is the f of x? It's 11, right? If x is 2, what's y? Y is 11. Nothing changed. It's the same thing, okay? All right. Now, here are some examples, right? Some examples of speaking functions and what they look like. So here we have g of x, right? We have f of x. We have absolute value of x, and then we have another g of x. Now, they all stand for different things. So this is, and again, we're going to go into more details later. This is a linear function. So that means if you were to graph this, it's a straight line, okay? This is a exponential function, okay? Actually, this is actually a quadratic function, actually. quadratic function because of the x square. So the graph looks something like this. It's a U-shaped curve, okay? Absolute value, right? So I'm just explaining the different kinds of functions, okay? Absolute value, this is an absolute value function. So this is why, by the way, you notice that what's the absolute value of -5? Yeah, +5, right? Absolute value function, the graph looks something like this. You would do this at the end of the year. Looks like a V. It's a V-shaped graph, okay? And lastly, you have a square root function, okay? Hold on, let's see. The lights just went off. All right, so a square root function, right? G of x is a square root function. And then again, we're going to look at that toward the end of the year, okay? And, all right, now, so some of you might say, Mr. Ng, like, then why do we keep using, like, f of x? Why don't you just say y, right? Here's the reason, all right? So if you put this in a calculator, it's better than all the equations in the calculator start off with y equals, okay? Because here, instead, I could use f of x, g of x, h of x. So that's a preferable way of presenting your functions, okay? And then it's also easier to tell which is the independent variable. Why? Because right off the bat, you're stating what's inside a function. Like what are you throwing into the blender? It's easier to see. Okay, so imagine you run like a juice shop, right? And you have a bunch of blenders, right? It's easier if you use a blender, right, where it's clear, like the cylinder is clear rather than it's opaque or completely covered, because now you can tell what sort of fruits, right, what sort of input value you put into the machine, right? Kind of the same thing. This just provides more transparency. Whereas this one, when you see a bunch of y's, right, it's not as clear, okay? Hopefully that's a good analogy. If you like that analogy, all right, please smash the like button and hit the subscribe button and hit the bell icon for notifications. Okay, all right, how are we doing on time? 12, let's see, you know what? Let me cap it at 12, okay? Because to go over this, it's gonna go at 15, so you know what? Hold on, let me press pause. All right, you know what? We gotta keep going. All right, so now, I'm gonna show you these examples. Not hard at all, because they're all evaluating functions, okay? And I always think that this is the best place to do this. So let me see if I could, let's see, do these 5, and then we'll leave the star later, okay? So hold on, press pause right now. Okay, all right, that took me no time to do because these questions are pretty straightforward. The only thing you really need to know is remember your order of operations. Okay, so these are the 5. So let's see what number 6 looks like. All right, let me press pause and take a good look at this because I also have the answer key. Hold on, let me press pause right now. Yeah, great question. So try this one on your own. I really want you to try this one on your own. Let's see. Okay, yeah, try this one on your own, all right? When you come back, I will show you the answer key, okay? So press pause right now. Okay, all right, and we're back. So here's the answer key. All right, and so what the person did, right, they substituted. All right, you guys can read the rest, okay? All right, so, yep. All right, let's move on then. All right, so again, if you wanna take some time to look at this answer key, press pause, but we're gonna move on, okay? All right, moving on now. Okay, all right, let's see. Now, the last one, you have to evaluate functions from a equation, right? Now we're gonna evaluate a function from a graph. So all you have to do is this, right? F of 2, meaning if x were to be 2, where would you find y? Okay, that's all right? So go ahead, try these 2 on your own, all right? And let's see, all right, press pause right now. Okay, since there are only 2 questions, I'm just gonna go over this real quick. So f of 2, so where is x equals 2? It's right here, 1, 2, right, on the x-axis, so it's point A. That's it, okay? Nothing crazy. Now, f of negative 3, that means if x were to be negative 3, what would y be? Now, I really should have made this bigger, because now I'm like, I have to strain my eyes just to do this. Okay, all right, let's see. F of negative 3, I gotta look at the screen real close. 1, 2, 3, so that's here, so I gotta go up right here. No, that means I gotta count. 1, 2, 3, 4, 5, 6. That's it. Okay, so the function of negative 3, right? F of negative 3 is 6. Okay. All right. Okay, that's it. Signing out. All right. Thanks for watching. 15 minutes, not bad. All right. Have a good day. See you tomorrow. Bye bye.
OMG, that was so good.